Hello guys and welcome. Today we are going to do price prediction using machine learning. I am your instructor Abdullah and we are going to also perform some hands-on practice with Python. If you want to learn more about AI, data science, machine learning, deep learning, please head over to our channel AI Sciences. Alright, so we are going to get started with an introduction to regression. We're going to look at our data set, which has been provided to you in the description below. It's actually an Airbnb dataset that belongs to a Kaggle challenge. And we're going to do some training and finally we're going to test our model. Alright. So regression is used for predicting continuous values. So any value that can that can be part of the real number line is called a continuous value. For example, price in our case. Now a price will depend on a lot of different factors. It could depend on the area of the house, the location of the house, the age of the house. If it's a newer house, it's going to be the price is going to be higher, right? And in order to plot it on the Cartesian plane, we have independent variables on the x-axis and dependent variable on the y-axis. So price is the dependent variable because it depends on the size of the house, the age of the house, the location of the house, right? So we the aim is to fit a line in such a way that the sum of distance perpendicular distance of all the points from this line is minimum. Now this is known as mean squared error, right? So the best regression line is going to be the one that has the least minimum square error. Another important thing is that the independent variables can be more than one dimensional, right? Meaning the dependent variable can be it depends on could depend on a lot of different variables. So we could have a linear line or maybe a curve to fit the data, right? So first of all we're going to start with importing our libraries in Python that help us code with different stuff, and we're going to load our data set and perform pre-processing, and we're all going to learn how to evaluate our models, and we're going to draw different conclusions from it. Right, so let's head to the programming IDE, which in this case is Google Colab. Now Google Colab is a perfect IDE for learning to program because it does not require any installations. You can just go right away and just get started with Python, right? So we are importing the libraries here and the data set right now. So we have the data set in this variable that is df, and if I print it right now, it's going to give me a big data set which consists of all the values of all the um, Excel file that we had raw with us. So this is the data set. Now this belongs to Airbnb. They actually recently launched a challenge on Kaggle to help them solve or predict prices given some you know variables. Now variables in this case are all these columns, name, host ID, longitude, latitude, room type, and everything other than price is the independent variable. All right, so we will be ignoring longitude, latitude, and the neighborhood, the location wise, all of the variables that dependent on location, because we want to predict Airbnbs that are other than New York City. Since this data set is specifically designed for New York City, we are going to drop all the variables that show the location or somehow indicate their dependency on location, right? So we have room type here, we have minimum number of nights, and the number of reviews, and all of that availability, and different variables that help determine the price of an Airbnb. Right. Okay. So let's get back to programming. And okay, so we just brought all the data with us here in a data frame variable, and you can use df.describe to get all the basic um, properties of the dataset. Meaning you can, for every column, which in our case is the variable, the independent variables, you can draw different summaries. You can draw, for example, the df.describe function is going to give you the count, mean, standard deviation, minimum, and 25% of the data, and all that information in just this small command. Right. So we have the description of our data set, and we're going to move forward and do the find if there's any null values. Right. So we are going to do is na dot sum. This is going to tell us about all the null values in our columns. So there's about 13 in name, 19 null values in host. Now null values are values that do not exist in the dataset. For example, here we have the reviews per month is 0 because there has never been a review to this Airbnb, right? So there can't be any reviews per month or anything. So these columns are empty, or they don't have any values. Now null values could be a result of loss in data, right? Or this data was never filled by the application, right? So we need to remove this data because it's going to make problems for us when we are training the data set. So this is known as data cleaning, right? Okay. So then we are going to set the index of our data frame. What we're going to do is set host as the index here, and we're going to take the host id dot values. We are going to take all the values of the host counts, and we're going to set it. Dot set index, and we're going to give it the name is count. You can say anything, count in, right? And then you can do adf equals adf dot rename and you can say that the columns equal, you can say that we need, since we need the indexes, right? So we can say that index should be renamed as, whoops, I need to get rid of this right here, and we can say that the index is renamed as host id, right? And this will make it easy for us to, now the index is very important when we are dealing with data frames, because this is the index is what gives a data frame meaning. So we have some reference, and we just, here we are going to concatenate these two data frames on the host id column, right? We're going to join them, we're going to merge them, and we have our data frame, right? So it says that host id is, alright, so host id, this is host id here. Let me just see. Oops. And we have to all right. So just just we are going to do the host id, we're going to reset it. All right, so there's some issue here, let me look into it. And it says that the columns equal, count in. So right, so we already ADF to reset number name equals count in, right? So what if I just alright, I got it. It's ADF here, so it's a simple spelling mistake that I missed. Yep. Alright, so let's print out the data frame here. We have just updated the index as you know, and we have different values here. All right, so now the next thing is that we're going to separate out the columns that we need for this particular problem, right? So first of all, we're going to just select all the columns that we need, and then we're going to move forward with that. Right, so moving forward to getting our number of columns that we really require, what we're going to do is we're going to just keep the relevant columns. Oops, I already copied this piece of code, so I think I'm going to remove the extra ones. So we're just going to have the number of columns that we're going to keep. Since room type, price, minimum nights, calculated host listings, and availability of the property, whereas number of reviews and number of the count in attribute, these columns are the most important ones, and we'll see why, right? Because price is going to be dependent on all of these after we have removed all the location based um, columns, right? Since we were doing it more than just for New York City. Alright, so our data frame is now reduced to 7 columns, right? Excluding the price column, that is the one that we're going to predict. Anyway, so moving forward, we'll have to drop the duplicates. We just do df dot drop duplicates, this built-in function for this thing. And we're just going to drop the duplicates here, so the total number of rows is reduced to 39,116. Next is that we have to make sure that all of the values inside the price column are greater than 0, right? Because any price that is less than 0 won't make any sense, because I mean all of them have to be greater than 0, right? So df equals df and df, which makes it reduces it to a column, and we just get all of the values that are greater than 0, right? So that was for data cleaning, and next we are going to look at some of the data visualization part. For that, I have also copied the code. We'll be using um, the Seaborn library for this, so you can just right away go ahead and copy this code. It's going to give you the distribution of this column, meaning this shows us that 80% of the data, if you look at this place, 80% of the data is less than 40 number of reviews. So anything above 40 reviews will be an outlier, right? So we have to remove these outliers, and you just you perform all of these functions on your different columns, right? For number of reviews, you could maybe write here minimum nights, right? We have that column with us, minimum nights, and we will do the same distribution. We'll use the same distribution function for it, and we're going to do it to distribution of, so we can just copy it here, right? So that is for minimum nights, where we see that at 20, oh I think it's for the bin width is 20, right? So you see how different it becomes for um, different columns. You have to just look at the distribution and you can know how it behaves differently for different functions, right? And using all of this information, we can you know remove outliers. So df equals df, and move forward with our data frame. We take this column with its minimum nights, and we make sure that it's less than 30, right? I have decided all these values after looking at probability distributions, and you can probably find better values for to fine tune um, your model, right? So we also take price, and it must be less than 500, because anything above 500 is an outlier for our code here. And we also must have all the availability. 365 must be less than 365, because anything greater than that won't make any sense. And df for I think number of reviews should be less than 100 for this dataset, right? So that inside the bracket, so that I think that's going to do it. So our data frame has now been free of all the outliers. We print it out and we see this as a data set. Now one problem that we have is that the all of the columns you see are integer numbers, right? And we have room type as private room, so it is categorical variable, right? And the categorical variables must be converted into ones or zeros or some number. So you can just assign it 1 2 3, any any IDs, or another way would be to perform one hot encoding. To do one hot encoding, we're going to do this little thing where we use a special function of data frames. We call it pd dot get dummies, right? Let's see, df room type, and you get it in one hot. If you get it in your you get a separate data frame for it, then you drop the room column from your room type column from your actual data set for x is 1, and you can just join them both together. You can say df equals df dot join hot, and print our data frame. So you see, now we have a one hot encoding, which means that you'll have one for every. We'll have 3 columns. The number of categories was 3, since private, shared room, or entire home, and the one that this row belongs to will be 1, and and the rest will be 0. So this is the best practice for regression, and it can be counted in your pre-processing as well. So I think for now we are going to just reset our index, because sometimes it's always good to reset your index, because data frames without good indexes will create a lot of problem. Alright, done. Right, so now we are going to split our data set into predictors or the predicting column, right? We use the predictors, and we say equals df dot columns, list and predictors dot remove, you know, price from, since it can't be a predictor, we have to predict that, and I think this must be it. Right, so now we're going to split our data set into train and testing. So we take the target column as, you know, give it the name price, right? And we say x equals df predictors dot value. So we have our values here and their labels as y equals, and we can say the target column dot values, right? So we have x train, x test, comma y train, comma test, right? So you have to split your dataset into train and testing, and for that we have the train test split. That was the one of the functions that we called in the library, and you can just train test set train set size to 20, which is always good, and you can say a random state equals to, right? And you can, you know, print their shapes. For example, I can just dot shape, and for the same I will do for the test split, right? So it says, alright, so we have to set use test size, because I just, oops, why didn't it type it here? Alright, so it's like this. Oops. Oh, let's test. Right, so we have the where our, you know, our different test, we have shape for test, and as well as for its prediction. So now I will just do the linear regression part, and we are going to call this linear regression model. We'll store it in a variable here. We'll fit the train against, we'll fit the train data with its labels, so the model knows what type of data is going to be, and we're going to find the mean squared error, the one that we talked about earlier, and the model is going to learn and it is going to predict. So a good model will have less mean absolute error and mean squared error, right? It's also called residual error. So there are different regression models, regression techniques that you can learn. You can always look into sklearn documentation. You just go ahead and try sklearn lasso regression or sklearn ridge regression. These are good algorithms and they have good results, right? You can also perform the decision tree regressor, right? So there's a special kind of regression using decision trees, and you can just perform, and you can just fine tune your model for different number of tree depth values, variables. You can always predict the parameters, and you can get better results. So that was it. I hope you've learned something new. You can always, you know, apply these techniques to your own real life projects, and you keep on learning. And do support us, give me a like, and, you know, support me in the comments. Don't forget to subscribe our channel and hit the bell icon. Alright, see you in the next video.